Welcome to Senior High School Math Series. In this video presentation, let us have deriving the equation of an ellipse under Senior High School PreCalculus. Let us recall an important concept that will be used in the derivation of the equation of an ellipse. The distance between 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2 on a rectangular coordinate system is given by d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. During the introduction to conic sections, we learned that when a plane intersects a double right circular cone at an angle that is greater than the vertex angle, a closed curve called an ellipse is formed. This time, let us have the definition of an ellipse. An ellipse is the set of all points P in a plane such that the sum of the distances of P from two fixed points of the plane is a constant. Each of the fixed points is called a focus. In plural form, it's foci. Imagine a string with ends fastened at the foci and then stretched using a pencil. As the pencil at P moves with the string taut, the curve traced is an ellipse. To find the equation of an ellipse, we take the origin midway between the foci and the coordinate axis on the line through the foci, this time the x-axis. We denote the distance between the foci by 2c, and accordingly label the foci as f prime at negative c0 and f at c0. Now, if we let the sum of the distances from point P with coordinates x, y of the ellipse to the foci be 2a, we obtain pf prime plus pf is equal to 2a. Hence, using the formula for distance between 2 points, we will have the square root of x minus negative c squared plus y minus 0 or y squared plus the square root of x minus c squared plus y minus 0 or y squared equals 2a. The equation that we obtained follows the definition of an ellipse, that the sum of the distances of point P in a plane from two fixed points of the plane is a constant. This time, let us start deriving the equation of the ellipse. If we subtract the square root of x minus c squared plus y squared from both sides of the equation, we can get rid of the radical symbol. We have x plus c squared plus y squared equals 2a minus the square root of x minus c squared plus y squared. We can get rid of the radical symbol by squaring both sides. Then we have x plus c squared plus y squared on the left hand side and 4a squared minus 4a times the square root of x minus c squared plus y squared plus x minus c squared plus y squared on the right hand side of the equation. Now, if we square the binomials x plus c squared and x minus c squared, we will have x squared plus 2cx plus c squared plus y squared, 4a squared minus 4a times the square root of x minus c squared plus y squared. Then for x minus c squared, we have x squared minus 2cx plus c squared plus y squared. Subtracting x squared from both sides, x squared cancels. Also, subtracting c squared from both sides, also y squared cancels by subtracting y squared from both sides of the equation. And then if we add 2cx to both sides of the equation, we will have 4cx equals 4a squared minus 4a times the square root of x minus c squared plus y squared. All terms can be divided by 4. So we have cx is equal to a squared minus a times the square root of x minus c squared plus y squared. Let us subtract a squared from both sides. So we will have cx minus a squared is equal to negative of a times the square root of x minus c squared plus y squared. There is still a radical symbol, so we can get rid of it by squaring both sides once again. So we will have c squared x squared minus 2a squared cx plus a raised to the 4th power on the left hand side, and on the right hand side we will have a squared times x minus c squared is x squared minus 2cx plus c squared, then we have y squared. By distributive property, we have a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared on the right hand side of the equation. So let us copy the terms on the left hand side. This time let us add 2a squared cx to both sides of the equation so that negative 2a squared cx cancels. And then let us subtract a squared c squared from both sides of the equation so that we will have a to the 4th power minus a squared c squared, and then subtract c squared x squared from both sides of the equation so that we will have a squared x squared minus c squared x squared plus a squared y squared. Then we can factor a squared on the left hand side so that we will have a squared times the quantity a squared minus c squared. On the right hand side of the equation, in the first two terms we can factor x squared times the quantity a squared minus c squared, and then let us copy the next term, a squared y squared. Now we will be needing another variable to represent a squared minus c squared. Since a is greater than c, a squared minus c squared is greater than 0. Since a squared minus c squared is greater than 0, we can use another variable to be equal to a squared minus c squared, and let us use b squared. Then we can substitute this to the resulting equation. We will have a squared b squared equals x squared b squared plus a squared y squared. This time, let us divide all terms by a squared b squared. On the left-hand side, we have 1. On the right-hand side, we will have b squared cancel. B squared over b squared is 1. So we have x squared over a squared. Next, for a squared, y squared over a squared b squared, a squared over a squared is 1. So we have y squared over b squared. Hence, for the ellipse, with the foci of an ellipse on the x-axis, we have the equation x squared over a squared plus y squared over b squared equals 1. If we take the foci of an ellipse on the y-axis at point 0, negative c, and 0c, we can obtain another equation. So let us have the rectangular coordinate system on the plane, and the 2 points or 2 fixed points, f prime 0, negative c, and f at 0c, and then we have a point P on the same plane with coordinates xy. The distance between the two foci is equal to 2c, that is f prime. And the sum of the distances of point P on the plane from the foci f and f prime is a constant, that is equal to 2a. Hence, from the formula for the distance between 2 points, we can have p f prime as x minus 0 squared or x squared plus y minus negative c squared or y plus c squared plus the distance pf, that will be x minus 0 squared, or still that is x squared, plus y minus c squared is equal to 2a. From the equation obtained in the previous slide, we can derive the equation of the ellipse when the foci lies on the y-axis. So let us subtract the square root of x squared plus y minus c squared from both sides of the equation. Then we will have the square root of x squared plus y plus c squared equals 2a minus the square root of x squared plus y minus z squared. And then squaring both sides of this equation, we will have x squared plus y plus c squared equals 4a squared minus 4a square root of x squared plus y minus c squared plus x squared plus y minus z squared. Let us expand y plus c squared, so we will have x squared plus y squared plus 2cy plus c squared. On the right hand side, let us expand y minus c squared, so we will have 4a squared minus 4a square root of x squared plus y minus c squared plus x squared. Then y minus c squared is y squared minus 2cy plus c squared. Subtracting x squared from both sides, x squared minus x squared is 0. Also y squared minus y squared, that is 0. We also have c squared minus c squared, 0. And then adding 2cy to both sides of the equation, we have 4cy equals 4a squared minus 4a times the square root of x squared plus y minus c squared. All terms of the resulting equation are divisible by 4, so we have cy equals a squared minus a times the square root of x squared plus y minus c squared when all terms of the equation are divided by 4. Subtracting a squared from both sides, we will have cy minus a squared equals negative of a times the square root of the x squared plus y minus c squared. We still have a radical symbol, so squaring both sides, we will have c squared y squared minus 2a squared cy plus a raised to the 4th power. On the right hand side, we have a squared times the quantity x squared. We can expand y minus c squared, that is y squared minus 2cy plus c squared. By distributive property, on the right hand side, we get a squared x squared plus a squared y squared minus 2a squared cy plus a squared c squared. Let us just copy the terms on the left hand side of this equation. We can get rid of negative 2a squared cy by adding 2a squared cy to both sides of the equation. And then we can also subtract a squared c squared from both sides, so that we will have a to the 4th minus a squared c squared on the left hand side. And then also subtracting c squared y squared from both sides, then we have a squared x squared plus a squared y squared minus c squared y squared. On the left hand side of the equation, a squared is a common factor, so we have a squared times the quantity a squared minus c squared. A squared x squared. On the next two terms, in the right hand side, y squared is a common factor, so we can have y squared times the quantity a squared minus c squared. Again, we can use another variable to represent a squared minus c squared. And since a is greater than c, then we have a squared minus c squared greater than 0. Then we can use b squared is equal to a squared minus c squared. Substituting b squared to a squared minus c squared in the resulting equation, we have a squared b squared equals a squared x squared plus b squared y squared. And then let us divide both sides of the equation by a squared b squared, so that on the left hand side we have 1, and then on the right hand side we have x squared over b squared plus y squared over a squared. So for an ellipse whose foci lies on the y-axis, The equation is y squared over a squared plus x squared over b squared equals 1. The properties and equation of the ellipse will be discussed on the next video presentation. That is all. Thank you for watching. Please subscribe for more math lessons.